So we have another lovely puzzle from Catriona Shearer. These problems are like jokes. You can only enjoy them once. So I hope that you think about it before you watch the video or look up the answer. This is a fairly easy one too. So maybe you can pause the video and take another shot at the problem. It feels so much better if you solve it. All right. So that's I keep saying that drawing a good picture is part of the steps, a very important part of the steps of solving the problem, because to draw a good picture, you have to understand the relations. You have to understand what's going on in the picture. For example, where do we start drawing things? Just gonna try to. So there is a vertical line that is split together, not half. And then this is gonna be sides of the square, and these are going to be sides of a square, but this is a little bit too small or too far, so I'm going to get a little closer because I don't want to split this line in half, but also this should be a square, right? So these two should be equal. And then on the other side, there is not much going on, so these two squares kind of have not much to do with each other or the triangle. So I've done better before. That's not my best picture, but you already see that there is not much going on here. If you want to be interested in the connections, there is much more going on the left-hand side. And we should probably know what the question is. The question is, what is this angle? You have to find that angle. And we can draw lines and stare at this and have ideas. You're not going to stumble into the correct solution all at once. But I guess it's a good question to ask. If I don't want to find that angle, what angle should I find instead? That will give me the same result, because that's often a trick with her. So this angle is 45. This angle is 45. This is what we want. But the idea that I want to present to you is that what if we found this skinny angle here? If we found that angle, that would be just as good, because that green angle plus 45 will give us the red if we just subtract them from 180. And as it turns out, this is the angle that we can find. Now we're going to chase down angles, but so as I'm trying to draw a picture, I realize that we don't even have to worry with the bottom square, because we switched from that angle to this angle. So that's extra stuff that we kind of we can afford to just lose. And so I'm focusing this triangle right now. And I think we can figure out the angle at C, because we're putting together a square. Well, that has a right angle there, and a regular triangle, which has a 60-degree there. So we can safely state that the angle at C is 90 plus 60, 150 degrees. And if we look at this side is as long as this one, because these are two sides of a square. Now the hunch is, okay, what if this side also equals to this side and that side? That would be really cool if that was true, because if this side equals to this side, then we have an isosceles triangle. And that means that we can call the green angle X, and it's X there too, and then 2X plus 150 degrees is 180. And therefore, 2X is 30 degrees, and X is 15 degrees. And how would that help? Going back to this tiny one here, tiny picture, if this is 15, then, and this here is 45, then the red angle is 180 minus 45 plus 15. So that's 180 degrees minus 60 degrees, and that's 120 degrees. So that's what I think the answer is. So the question is, okay, so do we have that fact that these two sides are equal? And the answer is yes. How did we get that triangle up there? Once upon a time, we had a regular triangle. And so this angle here is 60. And we cut this triangle with a parallel line. Oh, why is it parallel? Because those are squares, right? Squares have parallel sides. If this line is parallel with this line, that means that this angle here is 60 degrees as well. And that's enough. That forces the third angle to be 60 degrees. So actually, it looks like whatever we chop off from a regular triangle with a line parallel to its base is always going to be another regular triangle. That's what it looks like. And so that's the fact that gives us that triangle ABC is isosceles. So there we go. The answer is 120 degrees. Thank you for watching. Oh, let's check.